Good morning. My name is Farhan Siddiqui, and today we're going to be studying exception handling. So, you might ask, what exactly is exception handling? Exception handling is basically a way to handle runtime exceptions, and examples of these runtime exceptions can include class not found exception, IO exception, remote exception, etc. etc. If you code Java frequently, you are bound to have come across these names. But you might then ask, what exactly is an exception? So, an exception is essentially something that occurs during the runtime, which is during the execution of the program, and it's an unwanted or unexpected event and it disrupts the normal flow of the program's instructions. Then that is called an exception. So, what are some reasons why exception handling occurs? So, there's quite a few reasons. We'll go through a few of them, the most important ones. Probably the most common one is invalid user input. So, let's assume you're writing a code. In that code, you want the user to input the year in which he was born. Now, obviously, this is going to be an integer value, but let's assume the user has misinterpreted your statement, your question, and they have instead inputted a string. Now, obviously, there is a mismatch there because you're expecting an integer, but you've been given a string. That would cause an invalid user input, and that would throw an exception. Another reason could be errors in the code, because even no matter how good we are in coding, sometimes we are bound to make some errors, and that might cause an exception. We have then loss of network connection, and there's quite a few other reasons why exception handling could occur, such as being unable to open a file or being out of disk memory, etc. etc. So, what are the advantages of exception handling? There's quite a few. The most common one, the most advantage is that it improves the readability, and it does so by separating the error handling code from the normal code. This has the add-on effect of making the code easier to manage. This means that its maintenance and its management of the code becomes much easier. Another major advantage is uniform error processing. So in large projects, this is very beneficial because it enables uniform processing of errors. And finally, it's a fault tolerant program. What does this mean? It means that it enables the programmers to create clear, robust, and fault tolerant programs. Now, if you look on the image on your screen, you'll notice that there is an exception hierarchy. Now, a throwable class is the root class of the exception class, so that's at the top. And it has subclasses of error class and exception class. And these are subclasses that we're going to study more in detail right now in this video. So what is an exception class? An exception class is a class that handles conditions that the programs can reasonably deal with. They are results of some flaws in the program. So in order to better understand exception class, we are going to go and learn right now a bit about the examples of exception class, and that might give you an idea of what exactly exception class is. So these are some examples of exception class. The most common ones are arithmetic exceptions, array out of bounds exceptions, file not found exceptions, null pointer exceptions, etc. There's more exceptions, but presently we'll learn right now about these examples. Let's start with array out of bounds exceptions, because this is perhaps the most common one that you might have come across in your coding, and it's thrown when you try to access an element of an array that is beyond its range. What does that mean? Let's say, for example, you have an array, its length is 10, but you're trying to access its 12th or 13th element. In that case, an array out of bounds exception will be thrown because the 12th or 13th index of that array simply doesn't exist. Another example of a common exception is arithmetic exception. Now, this occurs when the program attempts to perform division by 0. So now, in real life mathematics, you cannot divide by 0. If you divide by 0, you get an undefined value. In computers, in a program, in Java, when you try to divide by 0 in your program, you'll get arithmetic exception because it's simply not possible. It's an exception. Then we have file not found exception. Now this is pretty self-explanatory. It's thrown when you're trying to open a non-existent file. And then we have null pointer exception. Now this one occurs if the JVM, which is the Java virtual machine, if it attempts to perform an operation on an object that is not pointing to any data. So now let's study some more examples of exceptions just to give you more clarity. String index out of bounds exceptions. And you've probably come across this as well, and it's basically the string version of array out of bounds exception. And this occurs when you're trying to access a character at a non-existing index in a string. Then we have input mismatch exception. This is the thing which I was talking about earlier in the video. It's thrown when a programmer tries to enter data which is not appropriate for the data type. So for example, you've written a code and you're expecting the user to input an integer, but the user, he inputs a string. So there's an input mismatch over there, therefore input mismatch exception. Then we have number format exception. Now this one is thrown if a program is attempting to convert a string into a numerical data type, but the string contains non-numeric characters. In that case, a number format exception will be thrown. And finally, we have IO exception, and this one occurs if the Java virtual machine fails to open an input-output stream. Now let's talk about error class. This class is used by the JRE, which is the Java runtime environment, to handle errors that are generally beyond the control of the user programs. So these are non-recoverable errors. So examples of this can include hard disk crash and being out of memory. So when I say non-recoverable, what do I mean? So let's take the example of a hard disk crash. Now let's just say the hard disk is crashed. Now this is not in the control of the program. This is something out of its capability, out of its hands. Therefore, it is called a non-recoverable error. It is something that is beyond the control of user programs. It's the same thing of being out of memory. So that is what you call an error class. So an exception handler will consist of 3 blocks. Those blocks are try block, catch block, and finally block, and each of them have a particular role and responsibility. Now the try block consists of the code that is likely to throw an exception. So let's go back to the example which I gave of you writing a code which you're expecting the user to input an integer, but you suspect that a user might input a string. In that case, that section of code, that chunk of code, you'll put it in the try block. Now what is a catch block? Catch block consists of the error handling code. In other words, what if an exception occurs? What if the user inputs the string instead of an integer? In that case, the code that is written inside the catch block, that is what will execute. And finally, we have the finally block. Now this is a block that will execute regardless of whether the exception occurs or not. So suppose that in your code you're expecting the user to input an integer and the user does in fact input an integer, there's no exception thrown, the code inside the finally block will still execute. It's irrelevant to whether the exception occurs or not. So there are certain rules now for try block, catch block, and finally block. What are those rules? Let's go through them now. A try block must be followed by either at least one catch block or one finally block. In other words, if you've written a try block, it cannot exist in isolation. There has to be a subsequent catch block or a finally block. It's up to you which one you want to choose, but there has to be one of either of them. Then a try block can be followed by 0 or more catch blocks, but only one finally block. What this means is that if you have a try block and after that you're writing another finally block, there can only be one finally block. There cannot be more than one finally block. And if you're adding a catch block after your try block, you can have multiple catch blocks if you want. That's up to you. And finally, the catch block and the finally block must always appear in conjunction with a try block. So these are the rules for try block, catch block, and finally block. So now this is an example of a code of which features try block as well as catch block, but it does not feature the finally block. So now if you can see in this code, user is asked to enter a number, then they're asked to enter another number. So there's a possibility over here of the number format exception being thrown. That is, if the user inputs non-numeric data. Therefore, since we suspect that, we've put this chunk of code where we are accepting the input from the user inside the try block in case an exception does occur. There's the possibility of 2 exceptions occurring here: number format exception, as you can see, as well as arithmetic exception. Now what is arithmetic exception? It's when you divide by 0. Over here, if you see in the code, int z is equal to bracket x into y divided by rem. So over here we're doing division and there's a possibility that it might divide by 0. Therefore we've placed this in the try block as well. Now let's come to the catch block. Now, as you can see, there are 2 catch blocks in this code. The first catch has in the brackets number format exception E. Now what this means is that if number format exception is thrown, then the code inside this catch block will execute. So what will execute? Flag will become false and it will print incorrect entry enter again. This will occur only if number format exception is thrown, that is if the user inputs non-numeric data. Then we have another catch block, and inside its bracket it says arithmetic exception error. Now this will be thrown only if an arithmetic exception occurs. If division by 0 takes place, then the code inside this will execute flag is equal to false, and it will print division by 0, enter again, and with that our code comes to an end. So this was one basic example of a code which uses try and catch block, and as you can see, it makes it much easier to read through. It makes it much easier to code as well. It's much more practical, and this is just one of the reasons why we use exception handling. So this was it for me. Thank you for watching this video. This was Farhan Siddiqui. Thanks everyone for tuning into Encrypt. See you next time.